Geometry is the area of mathematics that involves shape, size, position, direction, and movement. It's these characteristics that describe and classify the physical world we live in. Children's spatial sense is their awareness of themselves in relation to people and objects around them. Historically, geometry was one of the first areas of mathematics taught to young children. In the 1850s, Frederick Froebel, the father of kindergarten, designed a curriculum with suggested instructional practices based on the use of geometric forms and their manipulation in space. He called them gifts. In this curriculum, Froebel's gifts for kindergartners were special materials that enabled them to explore and grasp basic forms and relationships. The first 6 gifts included balls of different colors, cubes, spheres, cylinders, and complex sets of geometric blocks that children manipulated and observed in a series of progressive tasks. In later years, this geometric focus was largely lost. In fact, on an international comparison, the United States' worst performance in mathematics was in the area of geometry. Everyone acknowledges that the study of geometry and spatial sense has not been the focus in the typical elementary or secondary school classrooms. This is especially true in early childhood environments. Shape definitions are typically the only prominent geometric idea introduced, while the manipulation of shapes and spatial explorations are generally neglected. Young children have worked with shapes in art activities and puzzles and have constructed with Legos and unit blocks, which offer rich opportunities to explore geometry and spatial relationships. However, many teachers don't emphasize spatial concepts or take advantage of the natural connections to mathematics or other content areas. Familiarity with shape, structure, location, and transformation in the development of spatial reasoning will enable children to understand not only their spatial world, but also other mathematics topics. As children count the sides of two-dimensional shapes or the faces of a cube, they learn about number relationships. Patterns, functions, and even rudiments of algebra may be noted when children identify patterns in space and when they see the relationships between the number of faces, edges, and vertices of three-dimensional figures. When children compare shapes, directions, and positions in space, they develop concepts and acquire vocabulary that they also put in use in measurement. Grouping items, sometimes by their shape or other geometric features, is a skill also fundamental to data collection, and children may record and report shapes in an activity or in their environment. It seems that geometry is easily integrated into play through art, science, social studies, movement, music, and reading. For example, spatial skills emphasized in geometry are critical to the making and reading of maps, the examination of buildings and structures in our community. It's important that children recognize objects of all kinds and understand the geometric principles of them, and this will be replicated in their block play. Children begin to form shape concept in the early years before school, and these concepts are fairly stable by the time children are 6 or 7 in school age. For the most part, young children don't develop their concepts of shape from looking at pictures or hearing the words and definitions of a triangle and understanding that a triangle has 3 angles and 3 sides. Rather, it's really important that they handle, touch, manipulate, draw, and represent shapes in multiple ways to really understand the unique characteristics of them. The study of shapes should focus on the attributes and properties of both 2- and 3-dimensional shapes. Initially, children must be given many opportunities to sort the shapes, to manipulate them in multiple ways according to their own criteria, and really begin to think about the qualities of these shapes that they see and how they can organize them in ways that are meaningful to them. Matching or classifying objects by such properties really helps children to focus on the critical attributes of each shape. In addition to understanding shapes, it's important to think about where shapes are in space. Thinking spatially, the ability to visualize shapes in different positions and imagining their movements is important to young children's development as mathematical thinkers. Specifically, teachers should help children develop a variety of spatial understandings, such as location, movement, distance, transformation, and symmetry. Of course, learning to think spatially is an evolutionary process. It doesn't happen overnight. It happens over time with exposure to different types of spatial activities. In the early childhood years, experiences that start with simple maps and position words provide opportunities to understand objects in space, and then having the ability and opportunity to manipulate these shapes into various positions is important to children developing a spatial sense. Spatial skills are emphasized during routines or specifically planned activities. It's important to think about the different ways that we can help children develop these skills. For example, in the Dramatic Play Center, that would be a great place to emphasize specific spatial vocabulary. As children act out stories like the Three Billy Goats Gruff or the Three Little Bears, they can use position words that can be prompts for their movements. During guided reading activities, and we can also provide them with meaningful situations to move their bodies in ways that reflect the story. So really, spatial vocabulary is important, and it can be developed across experiences in the classroom, not just during specific math experiences. So we should be teaching kids about location and position, where objects are in relation to others. This is where we discuss when certain objects are on or off, on top of, over, under, out, onto, into, up, on the bottom of, above, below, next to. There's so many different positions that objects can be in. You should start simply with infants and toddlers and then become more complex as children get older and understand simple positions. You can provide them with opportunities for more complex positions. Then you also want to think about movement words and how an object moves and how that movement changes and direction changes how we think about the object spatially, such as up, down, forward, backward, around, through, to, from, forward. We move away from, we can move sideways, we can move across, back and forth. So really describing those different movements that we can do with objects. And next we need to be thinking about distance, the distance between two objects, and if objects are near or far, if they're close, and then we can also think about the longest or shortest path and using that sort of distance vocabulary to explain the position of objects. And finally, transformation. Young children are often unable to visualize what a shape will look like when it's turned or flipped. And so we need to provide them with opportunities to transform shapes. For example, if you have 4-year-olds practicing folding a square diagonally and cutting it into 2 triangles, they'll often be surprised when they realize that they can take the 2 triangles and put them back together and make a square. But this is an important experience that they need to have. The next is symmetry. A line of symmetry obviously divides a figure into 2 parts that are mirror or reversed images of each other. So for children to really further this understanding, it's important that we let them build on mirrors, use mirrors in a variety of play experiences, but also teach them about symmetrical relationships by drawing half of a picture or half of a house or half of a flower and placing it up against a mirror so that they can see how the image will become complete by using a mirror. Children enjoy also holding a mirror up to photographs and looking at making funny pictures of their parents with 2 heads and things like that. That can be really exciting and interesting for them to learn about symmetry. So these are important terms and ideas about focusing on spatial relationships of objects that's important to geometry.